Here is a real scenario. A developer needs to deploy code to production. The quickest solution: create an IAM user with administrator access policy. Give them the access key, deploy succeeded. 6 months later, that developer leaves the company. Those credentials still active, still have full admin access to your entire AWS account. Then one day, those credentials leak in a GitHub commit. Someone finds them, your entire AWS account is compromised. EC2 instances mining cryptocurrency, S3 buckets deleted, database exposed. This happened because most teams don't understand the difference between IAM user roles and policies and when to use each. Creating an IAM user with permanent credentials, wrong. Giving administrator access to everyone, wrong. Not understanding when to use role instead, wrong. Today we are fixing that. IAM policies versus role versus users, when to use each, why it matters, and how to implement principle of least privilege without breaking your workflow. Let's architect IAM properly. Hi, I'm Pratik Kumar Mohite, a cloud DevOps professional, and I built this channel for one reason: to help you think like a cloud native architect. Before we dive into users, roles, and policies, let's establish what IAM is and why it's the foundation of AWS security. What is IAM? IAM, Identity and Access Management, controls who can do what in your AWS account. So there are two core concepts: authentication, who are you, which is providing the identity, and authorization, what are you allowed to do, permissions. IAM handles both. Why IAM exists, and it's the security foundation. Every AWS API calls requires authentication and authorization. Creating an EC2 instance, reading from S3, updating a database, and deleting a VPC. Without IAM, no security. Anyone could do anything. With IAM, precise control over who can perform which actions on which resources. So there are three IAM components. First, IAM users, which represents a person or application. It has permanent credentials, password, or access keys. Example, a developer named Bob. Second one is the IAM roles, represent a set of permission that can be assumed temporarily. No permanent credential, and the example would be a role that EC2 instance assumed to access S3. IAM policies, JSON documents defining permissions, attached to users, roles, or groups. Example would be a policy allowing read-only access to S3. And what's the relationship between them? Users and roles are the identities, which defines who are you, and policies are permissions, which defines what you can do. So you attach policies to users or roles to grant permissions. And the architect's foundation would be understanding when to use users versus role is the difference between secure scalable architecture and a security nightmare. Let me show you each component and when to use each. Let's start with IAM users. This is what most teams reach for first, and it's usually wrong. What is an IAM user? An IAM user represents a person or application with permanent long-term credentials, which consist of passwords for AWS console access and access key for programmatic access like AWS CLI, SDKs, or APIs. The problem with IAM user is permanent credentials are the security risk. They don't expire automatically. If leaked, they are valid until manually revoked. People forget to delete them when employee leaves. They get committed to GitHub, hard-coded in application, shared in Slack. So when to use IAM users? Humans access to AWS console for a small number of administrators only. Root account protection. Create admin users and lock the root account. Only few people will have the access to the root account. Break glass emergency access. Highly restricted and MFA protected, which is a multi-factor authentication. When not to use IAM users, in most of the cases, application access to AWS, use IAM role instead. EC2 instance accessing S3, use IAM role for EC2. Cross account accesses, use IAM role for cross account. Temporary contractor access, use IAM roles with federated identity. Let's see a real world anti pattern. Application with IAM user credential. The bad architecture would be application has the hard coded access key and it's accessing any AWS services. So in this case, what happens? Access key is hard coded in application config, credentials stored in the source code or the environment variables, key rotate manually, and if keys get leaked, full compromise until the manual revocation. So let's see the right way. Use IAM role instead. The good architecture would be applications which will assume an IAM role and have the temporary credential. With those temporary credential, it can access the AWS services. In this case, what happens? No long-term credentials stored anywhere. Credentials auto-rotate every hour. If instance compromise, credential expire automatically. Revoke role to revoke all access immediately. There are some best practices for the IAM user, and you must use them. First one is to enforce MFA, which is a multi-factor authentication. So require the MFA for the console access and prevent the API calls without MFA, which is the policy condition. The next one is rotate access keys regularly, maximum 90 days per key. Use AWS Secret Manager for rotation automation. Monitor with IAM credential report. The next one is use groups, not individual user policies. Create IAM group, developers, admin, or read only. Attach policies to groups. Add users to that group and never attach policy directly to a user, which will be hard to manage at scale. Delete unused users immediately. If the employee leaves, delete the IAM user on the same day. Deactivate access keys for inactive users. Use AWS Access Analyzer to find unused credential. Never use root account. Root account has full unrestricted access. Create admin IAM user and lock the root account. Enable the MFA on the root account and store the root credential in the secure vault. Let's see the architecture's truth about the IAM user. If you are creating IAM users for application or services, you are doing it wrong. IAM users are for humans who needs console access. Even then, minimize them. For everything else, use IAM roles. Now IAM roles. This is what you should be using for 90% of AWS accesses. What is an IAM role? An IAM role is a set of permission that can be assumed temporarily. No permanent credential. Credentials are getting auto-rotated, typically every hour. Multiple identities can assume the same role and can be assumed by AWS services, users, or external identities. How roles works? So you define a role, create a role with trust policy, defining who can assume it, attach the policies. So add a policy defining what the role can do. Assume the role, services or user request temporary credential. Use the temporary credential, which will be valid for 1 to 12 hours and then it expires. When to use IAM role? In almost all the cases. EC2 instances accessing AWS services, IAM roles for EC2. Cross account accesses, assume role for one account to another. Federated access, SSO, Active Directory, or Google Workspaces. Third-party services, Datadog, Terraform, CI/CD accessing AWS. Let's see some real-world patterns. EC2 instance role, in which the scenario is EC2 instance needs to read files from S3 and write to DynamoDB. The bad approach when we are using the IAM user would be create an IAM user with S3 permission, generate access keys, hardcode those keys in EC2 instance, and application uses hardcoded keys. The problem with that is keys visible in the instance. If you do cat and AWS credentials file and that credentials are visible, keys don't rotate, and if instance is compromised, the key would be stolen. A manual cleanup when the instance is terminated. The good approach would be the IAM role. Create IAM role EC2 app role with S3 permission. Attach role to that EC2 instance at launch. Application uses AWS SDK to get the temporary credential and credential auto rotate every hour. The benefits with this approach are no credential stored anywhere, auto rotation every hour, credential tied to instance lifecycle. When you terminate the instance, credentials revoke immediately. Let's see another real world pattern where we need the cross account accesses. The scenario here is development account needs to deploy to production account. The architecture would be the development account where the IAM user is a developer. We have another production account where the IAM role, production deploy role. The trust policy allow developer account to assume this role and the permission are to deploy to ECS or update the load balancer. So the flow would look something like this. Developer, which is in dev account, will assume the role, production deploy role, which will get the temporary credential and then developers can deploy to production. Why this works? No permanent credentials in the production account. Centralize user management, development account, and audit trail of who assume role and when. If you revoke the role, instantly revoke all production accesses. Let's see another real world pattern, which is the federated access SSO, which is single sign on. Here the scenario is company uses Google Workspaces. Employees need AWS access without creating the IAM users. Let's see the architecture. Google Workspaces, which is the identity provider, and with using which we could do the SAML authentication to the AWS IAM identity provider, using which we can assume a role. The role would be Google Workspace developer role. We get the temporary credential, and AWS console access will be 1 hour of session. Why this works? No IAM user created. Google Workspace is the source of truth. Employee authenticate with Google credential. Temporary AWS console access, which will expire after 1 hour. And once the employee leaves the company, Google account is disabled and AWS access revoked automatically. Let's see some best practices of IAM role. The first one is use specific trust policies. So don't allow anyone to assume your role. Here is the example of a bad permission versus the good, where we are specifying the specific principle for the EC2. Use external IDs for third party access. When granting the third party services access, mention the external ID, which is the unique secret ID, which will prevent confused deputy problem. Third parties can't use your role for the other customers. Set maximum session duration. Limit how long assumed credentials are valid. The default would be 1 hour, maximum could be 12 hours. For most use cases, 1 hour is sufficient. Let's see the role architecture patterns. For every AWS service access, create IAM role with least privilege permissions. Define the trust policy. Who or what can assume it? Attach role to the service, EC2, Lambda, ACS, or any other AWS service. Service automatically gets the temporary credential and credentials are rotated automatically. No hard coded credential, no manual rotation, no security risk, and this is how you architect IAM in production. Now, IAM policies, the actual permissions. This is where you define what entities can do. So, let's see what is an IAM policy. An IAM policy is a JSON document that grants or denies a permission. Here is an example where we can perform the S3 get object operations. Let's see the policy anatomy. The first one is the version, which defines the policy language version. Statements are the array of permission statements. Effect is allow or deny operations. Actions is what API action are permitted. Resources, which is basically on which AWS resources this applies to. And we follow the ARN pattern in this case. Three type of IAM policies. IAM managed policies predefined by AWS. Examples are administrator access, full access to everything, read only access to all services, power user access, which is full access except IAM. Amazon S3 read only access to S3 service. When to use AWS managed policies? Quick prototyping or development, where we need the standard use cases, S3 read only or EC2 full access, and when to not use the AWS managed policies in the production because these are too broad and it could violate the least privilege. Specific requirements. AWS managed policies are generic. The next one is customer managed policies, and you create them. Custom managed policies for your specific need. Only specific IP can get or put data from S3. And here is an example where the resource is a S3 bucket prod app data on which we could perform the operations like S3 get object and put object with the specific source IP. When to use? Production environment where we need the precise control, when the least privilege enforced, specific business requirement, and when not to use the custom policies are the strict one-to-one isolation. Existing AWS managed policies already fits the use case, then use the AWS managed policy instead of custom policies. The next one is inline policies, embedded directly in the user and role. The policies attached directly to a single user or a role, and it's not reusable. And when to use the inline policies? One off permission for specific identity, ensuring policy is deleted when identity is also deleted. When not to use that, shared permission across multiple identities. Use custom manage instead. Let's see some policy evaluation logic. AWS evaluates policies in this order. Explicit deny. If any policy denies, access is denied. Overrides everything. Explicit allow. If any policy allow and no deny exists, access is allowed. And the next one is the implicit deny. If no policy explicitly allows, access is denied, which is the default. The key insights is deny always wins. Let's see the real world policy patterns, which is least privilege S3 access. Here the scenario is application need to read and write objects in specific S3 bucket. nothing else. The bad policy would look like this, which is too broad. The problem with that is access to all S3 buckets, can delete buckets, modify policies, violates least privilege. A good policy with the least privilege would look like this. And the benefit of these are access only to the specific prod app data bucket, can only read and write object, and cannot delete bucket, modify policies, or access any other buckets. Let's see another real world policy pattern for the time based access. Here the scenario is developer should only access production during the business hours. So here is an example of the policy where we are specifying the condition based on the current time. So access only between 9 a.m. to 5 p.m. UTC. Let's see some policy based practices. Start with least privilege, add as needed. Don't grant broad permission just in case. Start with minimum required permissions. Add more only when explicitly needed. Use policy condition. Restrict based on the source IP, time of the day, MFA status, or encryption status. Use AWS Policy Simulator. Test policies before deploying. Validate permissions. Identify overly permissive rules. Debug access denied issues. Version control your policies. Store policies in Git. Track changes over time. Peer review policy updates. Rollback if any issue arises. So let's talk about the policy architecture. Policy defines permissions, attach them to roles which is preferred or users. Always ask what's the minimum permission need for this task, and that's the least privilege. Now the golden rule of IAM, principle of least privilege. What is least privilege? Grant only the permission required to perform a task, nothing more. Not like give admin access because it's easier and grant S3 star because we might need it someday. Instead, grant S3 get object on a specific bucket because the application reads from that specific bucket. Why least privilege matters? It limits blast radius. If credentials are compromised, attackers can only perform actions those credential allows. Example, admin access compromise, the entire AWS account is compromised. Read only S3 access compromise, attacker can read one bucket, which is the limited damage. Prevent accidental damages. Developers with full access accidentally run AWS EC2 terminate instance with all instance IDs. With least privilege, command fails because we don't have that permission. Without least privilege, all EC2 instances are terminated. Compliance and audit. The regulation require least privileges. Auditors check can users access the resources that they don't need. Broad permission equals to audit findings equals to compliance failures. Let's see some real world least privileges architectures. Here the scenario is the web application with database. The application needs are read and write to the specific DynamoDB table, read from specific S3 bucket, and write logs to CloudWatch. The bad approach with the admin access are allowing everything, where we can do anything to any resource, which violates the least privilege. A good approach with the least privilege would look something like this, where we can only read write to specific DynamoDB table, not all the tables. Read from specific S3 bucket, not all buckets. Write to specific CloudWatch log group, not all logs. If compromised, attackers gains limited access. How to implement least privilege? Step 1. Identify required actions. What does this service actually need to do? EC2 instance, read from S3, write to DynamoDB. Lambda function, invoke other Lambda or write to SQS. Developers deploy to ECS or see the CloudWatch logs. Step 2. Start with deny all. Implicit. No permission by default. Add only what's needed. Step 3 would be grant specific actions on specific resources. So not something like S3 star on star, which is all actions on all buckets. Instead, S3 get object on a specific bucket, which is my bucket in this case. The step 4 is test and refine. Deploy with least privilege policy. Monitor for access denied errors. Add missing permissions one at a time. Never grant broad permission just to fix it. The step 5 is use IAM Access Analyzer, AWS tool that identifies unused permissions granted but never used, overly permissive policies, external access to resources. The step 6 would be review and audit regularly. So do the quarterly review. Are these permissions still needed? Can we reduce scope further? Are there unused roles or users? So let's see the least privilege anti patterns, and you should avoid them. Everyone gets admin, giving administrator access to developers to move fast. The reality would be the developers don't need admin, they only need the deployment permission. The next one is grant now and restrict later. Granting broad permission with the plan to restrict later. The reality is later never comes. Broad permissions becomes permanent. Copy production permissions to dev. Production needs write access, dev might only need read access. So each environment should have environment appropriate permission. Just use AWS managed policies. AWS managed policies are too broad, designed for many use cases. Production need precision. So customer managed policies with the precision is what fits here. The least privilege mindset. Before granting permission, ask this question: what specific action is needed? On which specific resource? Under what conditions? Time, IP, MFA, and for how long? Temporary access are preferred over here. If you can't answer this specifically, you are granting too much. The production IAM architecture. IAM users, minimal, only for human console access with MFA. IAM roles, primary, for all services cross account federated access. IAM policies, customer manage, least privilege, specific resources. Trust policies, explicit principle, no wildcards. And access review, which is quarterly, remove unused or tighten the permissions. This is how you architect IAM for production security. Here is what you now understand as an architect. IAM fundamentals, authentication, who you are versus authorization, what you can do. There are three components: users, roles, and policies. IAM users were the permanent credential, password, and access key, used rarely for the human console access or the break glass accesses, never used for application or services. IAM roles, temporary credential which auto rotates, used for 90% of AWS accesses, EC2 instance, Lambda function, cross account access, or even SSO. IAM policies, JSON documents defining permissions attached to specific users or roles. Always use least privilege, minimum permissions where it is required. Principle of least privilege: grant only what's needed, nothing more. Limits blast radius if compromised. Prevent accidental damage required for compliance. So the IAM decision framework would look something like this. When to use IAM user? Rarely. When the human console access is needed. When to use IAM role? Almost always. Service to service communication, cross accounts, or SSO. How to write policies? Least privilege, specific action on specific resources. The architect's IAM checklist. Ask for every identity: does this need permanent credential? No, then use roles. What's the minimum permission needed, which is the least privilege? Can this be scoped to a specific resource? Yes, then use the specific ARNs. Should this require MFA? And if it is a production access, then yes, MFA is required. Is there any audit trail? Cloud trail logging. The next video, we will see why every AWS architecture needs CloudFront and most don't use it right. What's your IAM challenge? Policies, roles, least privilege implementation? Drop it in comments. Subscribe to Cloud Native Labs for production focused deep dives every week. Now go architect secure IAM. Happy learning.